This video covers section 2.4. It's titled Applications Involving Percents, Ratio, and Proportion. And so we're going to really focus on those three things. We're going to look at how we solve equations and applications involving percent. We're going to solve applications involving interest. And we are going to work on solving proportions and some of the applications where we would use proportions. So first of all, just looking at the basic percent equation, it's the percent times the base. Percent times the base equals the amount. Percent times base equals amount. And you may have also heard it like this: the percent of the base is the amount. Remember, of can mean multiply and is can mean equal. So many times couple things to remember: the base is always the total. So when you're taking the percent of the base, you're taking the percent of the total. So we usually find, another way of saying that is we usually find the percent of the total. Remember, of means multiply. And then another important thing, we should whenever we're using the percent equation, we should always write the percent as a decimal. So let's look at some basic examples first. It says 84 is, so 84 equals what percent? So we don't know. When we say what, that's the unknown, so that's the variable. What percent of is multiply 175. So 84 is what percent of 175? Just like usual, we want to solve for x, so we're going to divide both sides by 175 to find out that percent, because that will cancel the 175s. You can do this in your calculator. You just take 84 divided by 175, and when you do that, you should get that x is equal to, and everybody try this in your calculator, 0.48. But remember, that's a percent, and we already reviewed earlier in the class how to convert decimals back to percents. We just move the decimal place 2 places, so that's actually 48%. So 84 is 48% of 175. It's just under half, or 50%. I'll try another one. It says 46 is, so now it's 46 is equals is 40%. 46 is 40%. Remember, convert that to a decimal, so we move the decimal place now 2 places back to the left, so that's 0.4 of times what number? X. So 46 equals 0.4 times x. And again, we want to divide. So this time we're going to divide by 0.4 on both sides. You divide by 0.4. Again, try this in your calculator. 46 divided by 0.4, that's 115. So we get x equals 115. Let's see what that would actually look like. So in your calculator, we take 46 and we would divide it by 0.4, and when you do that, you get that 115. So 46 is 40% of 115. Okay, the last one, what is? So that's the what. The what is the x, we don't know. So x is, anytime you see what is the x? What is equals 22%, move that decimal place, so it's 0.22 of, that's multiply 70. There's nothing to solve for. The x is already by itself, so we're just going to go ahead and multiply. Bring back up your calculator. 0.22 times 70, or 22% of 70, and that is 16.94. Now you have your answer. Now that's just some practice working with the percent equations. Let's do some applications now. So applications involving percent. It says 32 out of 160 students at a college are the first in their family to attend college. What percent of these students are first in their family to attend college? Now, notice this key word here, what. What is what? It's what percent. So the X goes in the percent. And remember, this is key. You always take the percent of the what? Of the total. So are we taking the percent of 32 or 160? What's the total number of students at the college that are first in their family? It's the 160. So we're taking the percent X, we don't know, of 160, or times 160. That equals the part, or the partial amount. This is the part. This is the total. And so if I want to solve for X, let's go ahead and write this off to the side. X equals 100. I'm sorry, I shouldn't say equals, I should say times. X times 160 is equal to 32. What do I need to solve for X? I need to divide both sides by 160. Divide that side by 160 and divide that side by 160. And we can do this simple enough in our calculator. X equals, and then we take 32 and we divide that by 160. And we get 0.2. Remember, we need this to be a percent. So this is 20% of students are first in their family to attend college. Now, some of you may have done this another way before, and that's fine too. Sometimes people like to set up proportions, and we haven't talked about this yet, but one thing you can do is you can say, okay, the percent over 100 equals the part over the whole. And so the setup here would be, well, we don't know the percent, so it would be X over 100 is equal to the part, which is 32 over 160, and then you would go ahead and solve that. We're going to talk a little bit later in these notes how to solve it, but a lot of you probably remember how to do this. Anyway, if you go ahead and solve that, you're going to get the same thing. You're going to get that X is equal to 20%. So I'm going to leave that idea for later, though, because I really think the percent equations are easier with percent problems. Let's look at another example. It says Nora bought a painting for $3,500. In 1 year, it increased by 18%. What was the value of the painting 1 year later? So we know our percent is 18%, which is, as a decimal, is 0.18. We move that decimal place over twice. So I can take this and make this 0.18. 0.18 of the total, that's the total value of the painting that she bought, is equal to some amount or some partial amount. So we can go ahead and calculate that. We can bring up our calculator here and take 18% of the total 3,500, just 0.18 times 3,500, and we get 630. Now, so basically 630 is 18% of 3,500. Now, what's the question? It says, what was the value of the painting 1 year later? Is that the answer? Is the value, is the painting worth $630, or what do we have to do with that $630? Hopefully you're thinking that we need to add it, because that's how much the value increased by. So we take 3,500, we add 630, and when you do that, you get $4,130 is the new value of the painting. Hopefully that makes sense. Now, we have one more example here. It says, Lee bought a new car for $30,000 3 years ago. Now it is worth $13,800. Find the percent of decrease in the value of the car. So we're trying to find the percent, and not just the percent, but the percent of decrease. So we know in our percent equation, this is what we don't know. We don't know the x. But we know our base amount. Our base amount is the value of the car, the original value, which is 30%. And we want to know the percent of decrease. So how much did it decrease by? What was the decrease? Well, it decreased down to that much. So to find the amount it decreased by, we have to subtract. We have to take the 30,000 and subtract 13,800. And when we do that, we get 16,200. And so that's how much it decreased by. It decreased by that much. So that's the amount of decrease. And so when we solve, we just take our x times 30,000 equals 16,200. And we know what to do here. We just divide both sides by 30k. Divide by 30,000. Cancels. And so what we're left with, we have our calculator, we have 16,200 divided by 30,000, and that's 50.54, which is 54% decrease, which is the reason why I say not to buy new cars, because in 3 years the value of that car decreased by 54%. They decreased most at the beginning of their life. Alright, let's move on to interest. And we're just going to be talking about simple interest here at the beginning of class. As we move to the end of the course, we'll start talking about compound interest. But right now, we just need to know this formula. Interest equals principal times rate times time. So it says a certificate of deposit pays 3.08% interest. Find the amount of interest earned in 1 year. So we have 1 year on a 5,000 CD. And look, so the principal, this is the amount invested. The rate, that's the percent, that's the interest rate. And then the time, this is in years. So it says find the amount of interest. So I want to know, in this example, the interest that is earned on a principal, the amount invested. Okay, so the amount invested was a $5,000 CD times the rate. Well, again, this needs to be a decimal. So when I move that decimal place over, if I take 3.08 and I move it over twice, I have 0.0308 times the time. Well, how long is this invested for? 1 year. So this is times 1. So if I multiply that all out, I just take my 500 times 0.0308 times 1, which doesn't do anything, and I get $154. So my interest here is $154 interest that's earned in 1 year. Again, you should always write this out as a complete sentence. Okay, let's move on to ratios and proportions. So, first thing is we're just going to define what a ratio and a proportion are. A ratio is a quotient of two quantities with the same units. So, example of a ratio, it's basically just kind of like a fraction. You could have 5 over 7. But it could be 5 apples over 7 apples. Same units. Whereas a proportion is a statement that two ratios are equal. So we could have 5/7 equals x/14. So we have a ratio equal to a ratio. And the way to solve this, you've probably done this before, is you cross multiply. So if you look here, we have a/b equals c/d. That's a proportion right here. What we can do is we can take a times d right here and say that that's equal to b times c. So we take a times d equals b times c. See how that works in an example. So here we take 18 times 180. We take 18 times 180. That has to be equal to this cross multiply, 40 times n. 18 times 180, that's equal to 3,240. And then we divide by 40. Divide that answer by 40, and we get 81. So my n is equal to 81. That's one. Let's do one more. Again, we're going to cross multiply. So we take 3 times 28. This one's a little bit more difficult, not a lot. It's difficult because when we do the second part here, 4 times n plus 12, you have to put that n plus 12 in parentheses because the 4 gets multiplied by the whole thing, which means we're going to have to do what on the right side? We're going to have to distribute. So we have 4 times n is 4n, and 4 times 12 is 48. So we have a plus 48. So we have 3 times 28. 3 times 28 is what? 84. And we know how to solve this. We're going to move that 48 to the other side, right? When we move it to the other side, it becomes a negative 48. So move that over here, it becomes a negative 48. And when I take 84 minus 48, what do I get? I get 36. All that's left over here is 4n. Divide by 4. 36 divided by 4 is 9. Okay. So we're almost done here. Let's go ahead and now look at an application or two of this. So it says in a certain city, 2 out of 9 adults have a college degree. So we know 2 out of 9 have a college degree. We're trying to use a proportion to solve this because we know 2 out of every 9 have a college degree. It says if there are 28,341 adults in the city, how many of them have a college degree? So how many out of 28,341 have a college degree? The 28,341 is going to be in the bottom because that's the total. Here, 2 out of 9 have one. How many out of this? So just the number on the bottom gets bigger. But we're going to solve the same way we just did. So we're going to cross multiply. We're going to take 9 times x. That has to be equal to 28,000 times 2, 28,341. 28,341 times 2, that's 56682. 56682. 5,682, or 56,682, and then we divide by 9. Come back over here, divide that by 9. We get 6,298. X equals 6,298 adults have a college degree in this particular city. One last example here, same thing. It says a basketball player makes 8 out of 12 free throws in the first game of the season. So that's our first ratio there. He can make 8 out of 12, or she, excuse me. If she shoots with the same accuracy in the second game, how many of the 15 free throws attempts will she make? So how many out of 15 will she make? So we do the same thing. 8 times 15 has to be equal to 12 times x. 8 times 15 is 120. And then if we divide both sides by 12, we get that x is equal to 10. So she will make 10 free throws. In the second game. Remember, write your answers in complete sentences when we have application problems. And that does it for section 2.4. Thank you.